calculus is based on the notion of limits. Question is, what are limits? We're going to look at an example here as an to show you what we mean here. So I want to look at the function sine x divided by x. Right? If I plug in a value for x, I can figure it out, right? What's f of pi over 2? Well, it's the sine of pi over 2 divided by pi over 2. I want to point out that I'm assuming that x here used inside of the sign is in radians. It doesn't say x degrees, so the measure for angles that doesn't have a label is radians. So anyway, I can evaluate this function. What's the sine of pi over 2? Well, that's 1, and then I'm dividing by pi over 2. So 1 divided by pi over 2 is 2 over pi, and there we go. I've evaluated that function. Well, I can evaluate that function at any value of x except what's f of 0? Well, first of all, there's a problem trying to divide by 0, right? But the numerator is also 0. And what do you mean 0 divided by 0? It could be the division by 0 is just not defined. This function is not defined. But I can plug in any other value of x. So the question is, what happens to the function value as x gets close to 0? And you might say, what do you mean by gets close to? Well, we'll find out what I mean here. So let's pick a value of x that's close to 0. For instance, let's look at f of 1. This would be sine of 1 divided by 1, which is equal to, I get out my handy dandy calculator, and I find that it's equal to 0.84147, whatever, right? Now, some of you may say, well, 1 wasn't really very close to 0. Well, let's try closer. How about f of 0.1? Right? And I get, I'm going to type it into my calculator, sine of 0.1 divided by 0.1, and it tells me it's 9983341, whatever. Okay, so that's 0.998. And then some of you say, well, 0.1 isn't really close to 0, so let's try something closer. I'm gonna make a table here. I'm gonna plug in x values, and I'm gonna top, and I'm gonna get f of x values down below here. So I plugged in a 1, I got 0.84. I plug in a 0.1, I get 0.99833, whatever. Plug in something a little closer to 0. I'm going to just keep getting closer and closer. So I'm saying sine of 0.001 divided by, not 00, just 0.01 here. And divide it by 0.01. And it tells me 0.9998333. Yeah, that's interesting. I can get even closer, right? I try it again. Whoops. With, let's say, 0.001. The hope is that at some point I recognize what's happening. So tried to type this into my calculator in a more efficient way, and it didn't really work. 0.999998333. Wow. Does this look like it's getting closer to something? I mean, it looks like it's getting closer to repeating all nines. So maybe the function's getting close to 1. Is sine x over x getting close to 1? Well, it looks like it. How about if I look at x is getting... I want to know what happens when x is close to 0. There's a problem at 0, so the question is what happens as I'm close to 0. Well, I'm getting closer to 0, but always staying on the positive side. Let's come up to 0 from the other side. So I'm going to make I don't know if I think of this as another table or the same table, but I'm just going to look at the same thing here, only let's take x's coming in on the negative side. So let's try -1 and -0.1 and -0.01 and see if something the same or maybe something different is happening here. So I'm plugging into my calculator now sine of -1 divided by -1, and it gives me 0.841. It's same as what I got there. Plug in a negative, so a -0.1. So sine of -0.1 divided by 0.1 gives me, divided by -0.1 gives me 0.99833. And I'm getting the same answer up there, and then I've got to think, maybe I should be seeing that this is going to give me the same answer. Because yes, of course, sine is an odd function. That is, the sine of -x is minus the sine of x. So if I plug a negative number in here, it's the same thing as putting a minus sign out front and plugging a positive number in there. Well, if x was negative, then x is negative here. When I divide, that becomes positive, back to what I had before. So it looks to me like this function is getting very close to 1. Yes. If I look at the graph of this function, in fact, let me go to my graphing calculator. So I've got my graphing calculator. I'm going to type in to here sine of x divided by x, save, and I just suddenly realized I want to check one thing here, make sure that my settings are in radians. They are, good. So let's look at the graph. And what I have is the graph of this function, and I notice as x is getting close to 0, let me zoom in here, as x is getting close to 0, this function seems to be getting close to 1. In fact, I don't even think my calculator app here realizes that at x equals 0 there's a problem. That technically there should be a hole in the graph there, because at 0 I don't know how to divide by 0. But as I'm getting close to 0, as x is close to 0, the function value is getting close to 1. Okay? In fact, it gets arbitrarily close to 1. The closer that I get x to 0, the closer that the output, the y value, is to 1. So the way I write this now, and this is what we're going to say, the limit, LIM, as x goes to 0 of this function, sine x divided by x, is equal to 1. This is the function we're talking about. This is the value that x is getting close to. And what it's equal to is the y value that the function is getting close to. Right? Now we're definitely going to have to talk about what do you mean by close. But there's an example of a limit.